Welcome to EDU World Space.
Let's determine whether this series converges or diverges by expressing Sn as a telescoping sum. And then if it converges, we'll go ahead and find that sum as well. So Sn, recall by definition, is just the sum of the first n numbers. Where your An is this thing that's being added up. So let's just go ahead and write this as a limit. K goes to infinity. And then we have the sum from n equals 1 to k, e1 over n minus e1 over n plus 1. Now this term here in the parentheses, this whole sum, this is sk. That's the sum from 1 all the way up to n, just as it's defined. So let's do a telescoping sum only inside of the parentheses, and then after that we'll come out here and take the limit, and that should answer our question. So let's write this. So now let's go ahead and start adding. So plug in n equals 1 first. That's our starting point. So e to the 1 over 1 minus e to the 1 over 2. This is the first term after plugging in n equals 1. And then next, you increase n by 1. So n is now 2. So n equals 2 there. Maybe one more term in this direction. So now n is 3. So plug that in. And you might see some cancellation happening already. So we would keep going in this direction. So put some dots there to indicate that. And then eventually at the very end, when we plug in n equals k, we'd have e to the 1 over k minus e to the 1 over k plus 1. But in order to maybe help you see the pattern here, it might be best to write a term before n equals k. So the term right before the last one, k minus 1. And by writing that, you can see some more cancellation over here. The e to the 1 over k will cancel with negative e to the 1 over k. So now let's see how much we could cancel. E to the 1 over 1. This doesn't cancel with anything because all the remaining denominators are larger than 1. Here we have negative e to the 1 half. That'll cancel with the positive e to the 1 half. More cancellation there. If I were to keep writing, I would see that e to the negative e to the 1 over 4 would cancel. And I would keep getting cancellation all the way until I get to e to the 1 over k. That will cancel. So this means this k minus 1 would also cancel with the term right before it. However, as I go all the way to the end, I see that I have e to the 1 over k plus 1, and that won't cancel because all the other denominators are less than k plus 1. So everything has canceled except e to the 1, and then negative e to the 1 over k plus 1. So let me write that on the next page. And then we have inside the parentheses, e to the 1, which is just e. However, as we take k to go to infinity, this term here, that's just e. But this term over here becomes 1 over infinity, which is 0. And so in this case, if we go ahead and plug that in, we just have e minus 1. And that's our final answer.